Hey everyone, and welcome back to another video series. In this video series, I'll be trying to program a autoencoder using pytorch. If you have been following this channel for a while, you know that I only use TensorFlow for all of my deep learning neural network needs. However, if you don't know that, then I'll just tell you that PyTorch is actually replacing TensorFlow day by day as the industry standard in deep learning neural networks. All the major companies, Tesla, Facebook, uh, uh, DeepMind, and OpenAI, all of them are majorly using PyTorch as their framework of choice. So in this video series, I thought I'd figure out how to use PyTorch by building a couple of projects. Now what I have done is I've opened up the PyTorch documentation. So this is all the documentation that PyTorch has. Now I have been told by a couple of people, and I've also seen a lot of people on YouTube saying that PyTorch documentation is pretty bad. If you compare it to TensorFlow docs, you will find that PyTorch documentation isn't as good. There are a couple of errors in it and stuff like that. However, this is what we're going to be using. We'll obviously use a couple of other blog posts and stuff to help me out, but this is going to be our primary resource to understand PyTorch, because I figure using the documentation is always the best thing, because it's made by the people who have actually made the framework, so they definitely know what it is that they are doing. They might have a couple of mistakes in there, but I think it's going to be majorly correct. The main reason is it's going to be more comprehensive. All right, so I'm going to make a new tab. Now I've also changed my setup a bit. So I've actually changed my keyboard, so I'm now using like a mechanical keyboard as opposed to like the Mac one. So you might hear a lot more of a clunky noise. If you don't like that, I'm sorry, but uh, it's just that long hours of typing on a Mac keyboard is just not very good for my fingers. So alright, so I'm gonna open up a Google Colab, and we're gonna do most of our coding right in here, mainly because it just provides me with a GPU, something that I don't have on my machine right now. So we're just gonna be using this. Alright, so we're gonna go into the Google Colab real quick. So the thing is, I'm expecting you already know what autoencoder is, so I won't be explaining that too much in detail. Alright, so I'm just gonna rename the file to pytorch autoencoder. Alright, now we can actually get started, and first let's just start with some of the basic stuff. So import torch, and I think we'll also just do this. Alright, perfect. Blah 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 blah. Oh, okay, I don't really care. Obviously, yeah, you gotta attribute stuff people if you are using autocomplete. So please do that. Don't just use the code as it is, because it is important to attribute the person who's written it. So these two people, I'm attributing Lionel7130, Drog S, and that's the project, and then blood image Thalanos shadowing. Yeah. All right, so I guess those are all the imports we actually we might need. Okay, let's actually, now I'm gonna be working with the MNIST digit dataset. So MNIST digit data download. So I'm gonna quickly go ahead and download the MNIST digit dataset. So let's write this one. Alright, so this is the one. So it's the MNIST dataset. Now this is, like, if you actually download it, you'll see that it is actually not this one. The one I want is a bit different. One second, I'll try to see if I can find it. Yeah, so the one that I want is the MNIST in CSV file. So basically it is a CSV file wherein they have kind of represented every pixel value like this. So this is the dataset we want to work with. I'm gonna go ahead and download it. The good thing about using a CSV file is the fact that it's only like 16 MB, so it's not a lot. Alright, so okay, I'm gonna have to sign in. So what I'm gonna do is I'm gonna quickly just shift to my video capture device. Alright, yeah. Okay, 1 second. I'm gonna shift to my selfie camera. There we go. And because I don't want you guys to see my email, I know most of you guys won't really do anything with it, but always a couple of bad apples, so let's just be extra safe. Alright, okay, I just logged in, shift back to my display capture, and let's just go ahead and download this. Nice. Alright, so are we done? Yep. Okay, so I'm just gonna quickly unzip this. Now there are gonna be two files. There's like a train and a test, and I think a val. Now right, so it's just train and test. Alright, so now what we're gonna do is very simple. We're gonna take these two files, we're gonna drag them over here. Alright, just say okay. It'll take a second or two for it to just do that. Alright, we'll close Finder real quick. Alright, it should happen. It usually happens very fast. I don't know why it's taking so long. Alright, so we're also gonna need pandas now, since we need to actually load this data in. Alright, why hasn't these two files finished uploading? Alright, so let's actually write the code to load them in. Alright, okay, I guess they have been uploaded. So we want to load in the train file, so we're gonna copy the path. I'm gonna just say pd dot read underscore csv, and I'll simply paste in the name of the file. Alright, so now if I just get the df.head, you should get a decent understanding of what the df kind of looks like. So just from the head you can get some really important information. So we get that first off, it's 28 by 28. I mean, kind of makes sense, and you can see that you have all these pixel values and stuff. So all of these, and then you have these labels here. So that's kind of what it is. So now what we want to do is we want to split and create like two lists, one containing the train images and then one containing the train labels. So train, let's get the train labels first. So train labels equals df. We're gonna get the label, and should we convert? Okay, alright, so what I'm gonna also do is I'm gonna convert it into a numpy array. Alright, so if I just get like train, now one thing I want to check is if I get train labels 0, and I want to get the type of that. So I'm going to say type of train label 0. What is that? Okay, so it's np.int64, and if I just run, oops, what is happening? Oh, okay, what's it? It's a new keyboard, so it's very hard for me to kind of acclimate myself. I'm constantly hitting like the wrong keys. Alright, so now if we just print train labels out, I actually wanted to check that. Alright, yeah, okay, that's exactly what we wanted. So okay, so we got the train labels done. Now one thing we're gonna have to check, actually I know for a fact it's not gonna be correct like what we want. So if I just get the shape of train labels, you'll see that it's only gonna be one dimensional, so it's only 2294 comma. I wanna add like a 1 over there, so I'm just gonna reshape it real quick. So I'm just gonna say train labels np.reshape train labels. Alright, that's pretty much all we really need to do. So now if I get the train label shape, it is now a 2-dimensional thing. As you can see, that's exactly what we want. So now we can go ahead and get the train images. Alright, so how exactly do we get the train images? So effectively what I want is apart from this. So basically what I want is I want to iLock on an index, and then apart from label I want to get everything else. So let's actually try to do something like that. So if I do something like df dot iLock 0, what do we get? Alright, so if I do that, I get a, okay, now this is something that we have to see. So this is kind of how you experiment in a Google Collaboratory or a Jupyter Notebook. You have to you first try something out, understand the data types, and then you kind of get an idea. Alright, so what I get is that you are getting a pandas series. That's important. So if it's a pandas series, it's actually very easy to work with. So what I will simply do is I'll just say for I in range len of df, and then I can just say column. Is it a column or a row? I think it's a column only. So also I just want to check one little thing, if you guys are able to hear me correctly, because as I said, I've changed my recording settings up a bit, so I was a bit unsure if you guys could hear me. I did run a couple of tests, but still. Alright, so column. So we do df dot iLock I and then we just want to get the digit pixel, so pixel vals, so that's going to be equal to call, and we want to call 1 colon, and what we also want to do is we want to do a little thing known as a to list. So we're going to convert it to a list, and then we also want to create a list over here. So it's going to be our train images list, and then we'll simply go into and just say train images dot append pixel vals. Alright, I think that's good enough. You're also gonna have to do a couple of other things like train images equals np dot array. Alright, we'll convert it to a numpy array, and now let's actually get the shape of it. Alright, there we go. So the shape is this. I think I should add a 1 to it to get the color channel, although I'm not sure. For now, I'll just keep it as this. Okay, I mean, one thing I also might want to do is, okay, so I'll actually have to do one little thing, which is that, okay, so one thing I want to do is I want to split the 2294 784 into 2294 28 by 28, because I think that's how usually it is done. So train images equals np dot reshape train images comma train images dot shape 0, and the way we get the dim, so the way we get dims is, now this is more of like, you don't really need to do it like this, but I'm just staying extra neat over here. I just get train images dot shape 1, and then I just go ahead and I divide it by 2. So that gives me the dim, since the image is a square, so that's kind of how it's going to be. Alright, so I'm just going to actually call it dim. So we do dim. Alright, so that should make it 2294 by 28 by 28. We'll also do one more thing, which is we'll go ahead and actually normalize the images, so the pixel values are between 0 and 1. So we just do a train images equals a train images divided by 255.0. Alright, I think okay, we have an error over here. Alright, why is that an error? Alright, let's take a look at this shape. 784. Ah, oops. Why did I integer divide by 2? I had to square root it. Stupid error. Alright, so instead of integer division, we have to do that. And instead of 2, we do a 0.5. That's pretty much all we really need to do. And of course, you need to do it as an integer. So we simply typecast it into an integer. Alright, there we go. Okay, so now we have our train images that have been normalized and stuff. So if I just do a simple plt dot im show train images 0, and we'll do it with a cmap. We'll just say cmap equals binary. So that kind of gives me like a black and white image, and then we can just do a simple plt dot show. Alright, there we go. It should take a second or two. There we go. So we get a phi showing up, as you can see over here. Pretty nice. Alright, so now we know that all of our data processing has been done. Now we can actually move on into the model. Alright, so what I'm gonna do is we'll go into torch.nn and we get all of this stuff. So basically this is all of the different what do you say, these are all the different layers that torch.nn has. So these are the basic building blocks for graphs. So you have a whole bunch of layers. So you have convolution, pooling, padding, blah 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 blah. We really just want to go linear, so we do linear layers. You have nn.linear, you have bilinear. I have no idea what this is, and I have no idea what lazy linear is too. Alright, but whatever. I mean, we have this stuff. Alright. Okay. We're obviously gonna Google. Okay, you know what I'm gonna do is I'm also gonna go into this part, and so here basically they have. So I know for a fact that there does exist something known as nn.sequential in here. So I'm gonna search for that. So nn.sequential, something like that. Okay. Yeah. So this is kind of what I want. So I want like a sequential thing. So this is what we want. Alright. Building a simple neural network. Okay, we'll just say building a digit classifier in pytorch. So we are just looking at like a very simple project, very similar to the one we are building. I mean, the interior network is different, but the data processing and stuff is pretty much just the same. Now, one thing that I've seen is that people just use like a pre-made data set. So apparently there does exist like a pre-made MNIST, just like TensorFlow has it. So even PyTorch has it. Alright, so you have a model. Now, I actually don't know how you compile and stuff these PyTorch models. I have no idea how that stuff works. Alright, so what I'm gonna also do is, okay, so I'm guessing they just use sequential. So in that case, what I want to do is I want to check out the documentation for a linear layer. So I want to take a look at exactly what kind of shape is it that they are expecting me to have, because that's kind of important. So alright, so if I pass in a linear layer, so you want the input thing and then like the output thing. Alright, so I think from what I can see and the way they have made all of this, I don't think they actually wanted to. Okay, I don't think. Okay, so I don't think these guys actually. Because over here, what I can see is that they have used a input size of 784, which means that if you know the equation for the hidden layer, the linear layer, it's just this one. And in that case, if this has a indem of that, it means they actually haven't done this step that we have done. So we're gonna have to get rid of that. we don't need it, and pytorch might just kind of cry about it. I don't really care, I don't want to deal with that, so we'll just do this. uh, Obviously this will not work then, because then you're gonna have to like reshape the data and stuff. I'm not gonna deal with it. We know that the data is there, so I'm not really caring about that now. Alright, so we'll make the model now. So model equals nn dot sequential, and what kind of format do you pass the data in? Alright, so we're gonna do nn dot sequential, look that up. Alright, there it is. So here it is. Okay, so I know for a fact what order dict is. Basically that kind of allows you to do everything a bit better. We're just gonna use this. Alright, obviously instead of model I also should be calling it encoder. I think I'm gonna make like encoder and decoder separate. I'm also gonna need one more input, so from torch import nn. So that's that. Alright, so now we can actually pass in our layers. Alright, so okay, let's look up what an autoencoder architecture looks like. So we are just building like a fully connected autoencoder. We aren't actually doing anything with convolutional layers and stuff. That's relatively too complicated for this video. Auto encoder architecture. Alright, we're gonna go ahead and check that out. I'm gonna look at an image because I think that's gonna be good enough. Alright, so this is the image we're gonna check out. And remember, when I made a video explaining how autoencoders worked, I actually used the same image. So yeah. Alright, so we have input, and then that's kind of squashed down into this latent representation or this coding dimension. And then you pretty much just use the exact same thing, but instead of that you just kind of scale it up into the output, which is pretty much the same shape as input. Alright, okay, pretty much that's kind of what it is. Okay, so we're gonna define a few constants over here. So actually when I say few, I can only think of one, which is gonna be our coding dim. So I think coding dim should be kept at something like 10. I don't think we need anything more than 10, because actually even 10 might be a bit too much. I have no idea. For now let's just keep it at 10. Alright, okay, coding dim is 10. Let's actually get started. So let's do how do we actually do it? Okay, so we just say nn dot something. Alright, that's cool. So we do nn dot linear. Oops. Alright, so indims are gonna be 784, and let's just do 128. Then we do nn dot linear. Now here the indims are gonna be 128, and let's just do 64. And then we're gonna do one last nn dot linear, and here it's gonna be obviously 64, and then it's gonna be coding dim. So this is our encoder. It's a very simple encoder, as you can see. It's actually very simple. Currently this is very similar. The equation that I'm using for this is actually very similar to the equation that you would use for something like linear regression. Reason being, I haven't actually added an activation function to this, so we kind of had to add that. Alright, so I have no idea how to do that, because I mean I know for a fact you do not add it like by putting a comma or something. Alright, so I'm just gonna search for, since I'm gonna use relu, so I'm just gonna search for relu. How do you use that? You add that. I just want to figure that out. I know for a fact you add it in as like a layer, so they treat the non-linearity as a layer. So alright, so this is kind of how we do it. One thing I can certainly see, coming from TensorFlow, I can see that the code, it's a lot more simpler. It's almost too simple for me to kind of wrap my head around it. Like, they're basically doing everything a bit more, I would say. I mean, when I use TensorFlow, it's sophisticated in many ways, but it's still very difficult to use. Something I don't really like. Alright, so I don't think we need an activation function for our last layer for now. I'm not gonna really add anything. So now we can pretty much work on the decoder. So nn.sequential. Alright, so here it's just gonna be nn.linear. I'm gonna code that out. I really wanna type. So and coding them, this goes out to a 64. Then we do nn.relu, nn.linear again. Alright, nn.linear. We outputted a 64, so this takes in 64, outputs 128. nn.relu, and we're gonna do a couple of things over here. So then we do a 784, and now I'm gonna have one last layer, which is gonna be a nn.reshape. Okay, I wanna see if there's like a reshape layer in pytorch. So nn.reshape. I don't think there is. So we won't reshape it, we'll do it in like afterwards when we are plotting. I figured I'd reshape it and then just directly plot it, but that's alright. Okay, okay, so they are using sigmoid as the last thing apparently, so we're just gonna go ahead and do that. It doesn't really matter. Alright, let's run this. Alright, I mean, I didn't really expect any errors. Now comes the hard part, actually training this. Alright, so obviously one thing that I know for a fact is I have to train the encoder first and then the decoder, because I mean that's kind of how it is. Alright, so how do we actually write a alright, so I mean now there are a couple of things that I need to know. Is that what loss function is generally used with an autoencoder? So which loss function is commonly used with an autoencoder? So you can just search that. Not this one. Okay, so they use. Okay, so we can use mean squared error. Alright, we're gonna use that for now. So we're gonna search for that, how we can actually define that mean squared error MSE loss. So this is one we want. Alright. Okay, so we just do that. Okay, so we do loss equals nn. I want to type it out. Now the reason why I'm typing it is because this helps me retain what I'm doing, at least in my case. A lot of the times I'll go ahead and copy it and I'll paste it, but the thing is I'll forget, and I don't want to do that. Since I'm planning on shifting to pytorch for the good now, I don't intend on using TensorFlow anymore. I know that's kind of an announcement, but I just, I figured it was time. So yeah. Alright, I mean, believe me, if TensorFlow decides to become a bit better in terms of complexity, I mean, Keras does do a good job, but still. Alright, so obviously you do output.backward afterwards. That kind of makes sense. Alright, okay. So you do that. Okay, now I don't need to do these two things. Here's the deal. So this is what we want to do, something like this. So I obviously want to define the optimizer also. We're gonna use Adam. So let's just search for that. It'd be actually, let's try Nadam also. We're gonna try Adam and Nadam. I'm gonna check out what Nadam is. I have a video on optimization. You can check it out. And again, if this equation looks like crazy to you, again, check out my video on optimization. Actually go through this equation. It's actually not as bad as it looks. Alright, so how do we define it? You just do torch.optim.adam. Alright, so optimizer is torch.optim.adam. Which parameters do we have to pass in? So we do params. Um, okay, so you do have to say which parameter. So you have to say model dot parameters, I guess. Okay, so you can set like a learning rate and beta and like all of this stuff, the decay factors. I'm not really gonna set anything. I'm okay with what they have given. I mean, the learning rate is small enough. Uh, you could maybe increase it a bit. I mean, in this, it's not like make or break if your learning rate isn't the best. So you could change it. I'm not gonna do that. Okay, but now here's the deal. I have a encoder. I have a decoder, but they are both separate. You know what? Actually, I'm gonna fuse the two together. So we're gonna just make one thing, which is gonna be a model, and then we're gonna put our encoder and decoder in. Yeah. So this is what we're gonna do. All right. Perfect. So we get optimizer model dot parameters. All right. So now I have to set the epochs. So all right. Alright, you know what? Instead of looking at this article, I'm just gonna look into what they have done. You know what? Let's just search for autoencoder. Have they written anything on that? Okay, they haven't. Alright, so let's just search for training loop. I mean, they should have something on it, right? Because it's kind of important to know how you can actually build a training loop in PyTorch. I wish they had something like compile and fit like TensorFlow. It was like much simpler. Obviously, for like more, shall I say, advanced networks, you have to use the. Okay, so what have they done? So flattening it. Okay, that's different. So firstly, you zero the grad. You also have to set like a running loss apparently. Let's just define that in here. So okay, first thing we do optimizer. So it makes sense why I wanna zero the grad of the optimizer. Oops, why did I do that? Our model is not defined. Oops, I forgot to run this. I don't think I need to pass that in. 1 second, let me just add in. Have they given us like an actual example whether we used Adam? Because I want to check that out first. I guess this article is a bit outdated. Okay, yeah, it is 5 years old. Damn. Okay, I should have used like a more of a newer article. So okay, let's just use the one that's given on PyTorch. All right. Okay, so these obviously they are using like a more complex data set. If you don't know, this is a CFAR 10. One good thing is they aren't using like CFAR 100 or anything like that. All right, so they are running it over just 2 epochs. I can see. So you zero the okay. How did they define the okay? So okay. One thing I mean, they are defining the entire thing as a class. You know what? In a way, it makes sense. I could do it something like that. Should I? I don't know. I mean, look, they are specifying parameters, and I don't think I can get that because it is saying that it actually can't. Alright, so what we're gonna do is we're gonna have to define it as a class, which kind of sucks. Also, you know, okay, so we can just do class. Okay, you know what? I'm just gonna do C. I'm gonna do class. Can they do the auto completion for us? Oh my god, that's so cool. Alright, so can I just do something like this? Like, can I just do that? Because if I can do that, then that is just sick. Alright, so we can just say autoencoder dot parameters, and what I'm gonna do is I'm gonna first just run this autoencoder. Okay, yeah, so I'm gonna have to run this and this. Autoencoder has no attribute parameters. Okay. Okay. Why on earth are they not? Are they giving me that stupid error? I mean, I know that this won't really make a difference, but still, maybe it does. Who knows? Oh, come on. Alright, okay, maybe if I just have to, maybe I'll just have to define the whole thing. That kind of sucks, bro. You should have a better way to do this stuff. Maybe I'll just use TensorFlow. Nah, I'm not gonna do that. Alright, okay, but apart from that, what else are they doing? So get this. Okay, one thing I don't get is why are they getting it like, are they setting a batch size or what? I have no idea. Oh damn, I just realized my stupid error. Okay, I know it wasn't pytorch that was dumb, it was me. I forgot to create an object. Seriously, that was like some crazy errors that I made. Let's see. Ah, come on, for God's sake. Alright, let's see. Apparently, you needed that. Ah, you gotta be kidding me right now. Why on earth am I getting this stupid error? Alright, let's test something. Alright, let's test something. I'll make a new code block. Alright, I'm gonna make a new code block. I'm gonna copy that, paste that in there, and we're gonna copy that, paste that in there, what on earth is F? What is f dot value? Okay, I know that was just an dot function. That's all right. Okay, I forgot to do this. Okay, does it throw me an error or not? Okay, so this does not throw me an error. However, that did. So whatever the error is, has to be somewhere. I mean, this stuff is practically identical. I don't see anything that's off. Okay, so the only thing that I think is off is that yeah, I think that I think there's the only one thing that's off, which is that I'm just gonna have to define all of these layers by myself, which kind of, oh god, I really do not want to do that. Sucks. All right, so we're gonna just go ahead and do that real quick. Let's just do it. I mean, come on. Self dot e1, so encoder 1 is nn dot linear 784 128. Self dot e2 is nn dot relu. Self dot e3 this code, I mean, I'm pretty sure there's like a million other ways that I can do this a lot better. It's just that I have to be a bit more familiar with pytorch to actually do something like that. Self. Alright, there we go. Okay, now we can start with the decoding stuff. So we can just do a simple that's exactly what we want. And we're gonna need this. Alright, now we're gonna have to forward all this. So x equals self dot, we do that, and x, we do that. So this is the good thing about Jupyter, about Google Colapse. It allows you to do some stuff like this, which is pretty cool. So we return x, and hopefully we don't get an error now. Super argument should be autoencoder. Copy that. Paste it right in here. So we're gonna paste the exact same thing. Alright, I mean, obviously one thing I'm gonna have to do now is just tab this, indent it right here. God damn it, stupid errors. And why am I not getting an error over here? Maybe it's because of the inputs that I'm making. Is that the reason? I could make that input up top. Then I'm gonna get rid of this entirely. So there's no scope for error on that side. And then we can just define it as net. Alright, so we don't get an error now. So now if we run that, we still get an error. For God's sake, what the hell is wrong with this? It's still, I mean, it's literally the same thing. Alright, you know what? Let's literally copy every single thing that they have done. If we still get an error, then at this point I don't really have any ideas. We're gonna go ahead and pretty much paste that in there. Alright. Please work. You know what? I'm gonna call this to net. I mean, it cannot get any more similar than this. And now it works. Okay, I don't know what stupid error I was making. No, did it not work with Adam. Let's change it to Adam now. Please work. Alright, so now we can get rid of LR and momentum. We can use LR, but I'm not gonna use that. Please work. Alright, so now it works with Adam. I have no idea what was wrong, but apparently there was something off. Alright, whatever. Alright, you can do that. Oops. What on earth am I typing? There's a lot of changes in muscle memory with a new keyboard, that's for sure. Also, I'm using like the big keyboard now, the like 120 or whatever you want to call it thing. It's not the 60% like the Mac keyboards are usually. So yeah, it's a pretty good keyboard actually. Blue switches, so it is pretty clicky. Alright, so we finished this. So next what I can see is they are loading in like a batch of data together. I'm guessing that's a batch. I'm guessing it's not like one thing. Alright, so we're gonna instead of doing a batch, we are just gonna load in one thing at a time. If it is too processing heavy, then we could just go ahead and maybe uh, I don't know. We could maybe just go ahead and like either clip the data to a certain amount, or we could do batching. I really don't want to do batching because that's kind of boring and it could mess up some of the shapes that we have, which I really don't want to do. So that's kind of why I don't want to do that. All right. So okay. So they do for I comma data and enumerate blah blah blah. Okay. So I mean, pretty much they're doing that just to get the data. In our case, I can just do a for I in range length of train. Okay, I did not spell that correctly. Okay, so we can just do that. Okay, that's nice. Alright, so now they do an optimizer.zero grad. Did they do after or before? Okay, so you do it. Okay, so you gotta. Oh yeah, makes sense. You wanna zero the grad every time you're in there, because yeah, that makes a lot of sense. That would have been a pretty major blunder, one that would have been hard to debug actually. So yeah, okay. So with pytorch, one thing I can see is that it's got a lot more finer grain control over what you're doing. I mean, you can do this in TensorFlow as well, but I mean, if you see like a beginner's tutorial, you really won't see anyone doing something like this in TensorFlow. You can write custom loops and stuff, but come on, it's not something you learn unless you really want to do TensorFlow. All right, so we can go ahead and just say, all right, so let's just go ahead and do this. As I said, even though I'm not a big fan of copy pasting, we aren't perfect, right? So I'm gonna go ahead and do that. All right. It's pretty much just the same stuff. All right. Now inputs over here. What is inputs? Okay. Oops. Okay. So we can just call it inputs, and we can make this labels. And for criterion, instead of criterion, we can just call this loss fn, which is loss function. And instead of criterion, we can just pass in loss function. All right. I think that's good enough. Actually, we need to do a. Okay, now this basically prints out like the statistics for the model, like running loss and stuff like that. It's not core to the model training, but you obviously want to know what the model statistics are. You want to, I'm sorry, model like whatever you want to call it. Okay, I'm gonna have to do one more thing. Unindent this like that, and another thing. So epoch. Alright, that's pretty much it actually. So for now, what I'm gonna do is I'm gonna do one little thing. So we're gonna get the first 500 elements. Alright, we're gonna get the first 500 elements, and we're gonna do all of this stuff on the first 500 elements. Alright, for now I just want to do that. Okay, first error is that linear argument must be tensor, not numpy. Okay, so apparently you can't do that. So in this case, I really just need to do a simple. I hope it's simple. Torch dot tensor. Right, let's just do that. Torch dot tensor. I guess that's it. Tuple object is not callable. So it's literally just there in E2. So we're gonna have to check out. What is there? I can't understand that. I don't get it. What is the error? I actually don't get the error itself. What do you mean tuple object is not calibrated? I'm pretty much doing exactly what they're doing. It should work, technically. Because it's breaking in the second layer. Like it's doing this. It's getting a problem over here. Okay, let's take a look at what it means in this case. Oh, okay. So you're calling a tuple as a function. That's the error over here. Alright, that makes sense. Okay. So how do you actually get rid of that? I mean, what is the error over here? I mean, I don't get that. Because it is correct, technically. I'm literally doing the same thing. I'm just using like a different layer, but it is, well, the same thing. Wait a minute. Okay, so they're using nah, but that's for the activation. They are using that on the X. I don't get it. Why am I getting that stupid error? This does not make a lot of sense to me right now. Can it help me explain it a bit better? Maybe with some context. Explain error, please. I mean, if this was TensorFlow, we'd probably be done like a long time ago. Okay. Is that the real error? I have a comma somewhere? Oh my god. I'm so happy that there was Gemini to help me out on this. There's no way I would have figured out that there was a comma. There's no way I would have figured that out. The thing that I'm kind of pissed out about is the fact that they actually did not show that as a syntax error. I figured that would be a syntax error. Like, it kind of should. I don't know. I'm just maybe not. Maybe I'm just not that good at Python. Who knows? Alright, so it seems to be working. Alright, so it finished training, apparently. And it makes sense why it's not printing every 2000 minibatches. Makes sense. Alright, so apparently it has finished training. Now in this case, what I want to do is I want to do one little thing, which is just this. I'm going to copy that. Instead of doing every 2000 minibatches, we'll do it every time. Since I'm currently only working with like 2 of these. Okay, so the loss is very less. It probably just could be lying to me in some way. I have no idea. Because, okay, I should have printed it over some extra mini batches. Okay, so the loss is not that high. There's like a very, very small loss. which is a good thing. Obviously, right now the model is probably going to be grossly overfit. Okay, so now that we have finished training, we can actually do some kind of inference, some kind of testing, something on it. All right. Okay, let's do some of that testing, eh? Okay, so I really don't care about that. All I want to know is how do you actually do the predictions? Oh, that's cool. I mean, you literally just run that on the images. That's actually pretty neat. Okay. Okay, I just realized a very stupid error I made. Okay, that's a very stupid error I just made. Okay. I have no idea how I made that. Okay, what? Okay, so here's the deal. I was making an autoencoder. Why on earth did I even load the labels in? I'm not making like a conditional autoencoder, like a variational autoencoder or something like that. I'm making a autoencoder. I do not need labels in any way. But I still went through such a pain reshaping the labels, blah 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 blah, all of that stuff. That also means that the loss function I'm using is probably wrong. It kinda sucks. Okay, so I'm gonna need some help for this one because I have no idea. Okay, so we're gonna just Google it up. Uh, Autoencoder. Oops. Autoencoder in. Now I really don't wanna get any pytorch references on this one, so I'm gonna say autoencoder in TensorFlow. I really do not want to get any PyTorch references, like PyTorch specific stuff that you could do. I want to do it by myself and then I want to see how someone else would have done it. So I'm going to go down here. Okay, what I want to know is, okay, so they are using mean squared error. Oh, so you just pass in X train as both the input and the target. That is trippy. So you obviously can't do outputs and labels in this case. No, wait a minute. So outputs and this goes into inputs, right? I guess that's what I want to do. For now, we're just gonna print out the running loss. You know what? For now, let's just print. It's probably gonna throw me an error or something. Who knows? I guess what I'm doing is correct, but I have no idea. And frankly, I really don't have any way of saying it's correct or it's not before I actually get the output. Okay, so it's on the 7th epoch. It really does not have a lot of images to actually train on. Granted, I was the one who actually did that, but still. Alright, cool. Okay, we're gonna obviously do that. Alright, let's just do this and paste that here. So this is kind of like the moment of truth over here, that's for sure. And we're gonna do that on, let's say, oops, what did I just do? Okay, now I'm just gonna do train images 0. I don't really care. All I want is okay, what's the error over here? You gotta be kidding me. Okay, I just gonna do a torch dot okay. So one thing that TensorFlow was good at is it kind of was okay with the fact that okay, you can okay, you know what, I'm gonna keep it as a tensor. Outputs dot shape. Okay, so we can do okay, so outputs equals torch dot okay, when you want to search for that, reshape, so outputs 28 by 28. Alright, so we can now run that invalid syntax. Oops, just do this. Alright, now that is pretty good. plt.imShow output. Don't really expect anything. Believe me, do not. It's taking a second. Alright, so we're gonna do outputs dot detach. I have no idea what detach means, like what it does. Numpy. Alright. Oh my goodness, we actually get an output. It's very bad, but it resembles a number. Sort of. Now here's it. You cannot expect something good from it. You just should not. Believe me. It looks more like a 3 than a 5. I mean, I get it. But here's the deal. What we are training this model on and the type of model we are training, it's very simple. It's a very simple model. It is not built to do this. Okay, now one thing we can do absolutely is increase the size over here. Now for that we're gonna do two things. One thing we're gonna do is we're gonna do that, and what we can do now is instead of 500, imagine if we just do it on 1000. How does that change the model performance? You will probably see that there will be a much more of a drastic improvement. So it's kind of like a logarithmic thing. You increase it more and more, and it's gonna. One good thing is we have a GPU over here. So and this is where a GPU kind of works out very well. Since we aren't doing any batching, we are running it on every single thing. Now that's actually, you know what? That's actually another major thing over here. We aren't actually doing any batching. Now the reason why that's a big thing is because it is giving me a relatively bad, but I mean an actual output when I gave it only 500 images without batches. Imagine if we did have batches. It would have been just horrible. Alright, so it's gonna take a second. It's obviously gonna take a couple of seconds to do this. You can't really expect it to do it very fast. I think we are almost done. Yeah, there we go, we are done. Oh, damn, that actually resembles a 5. Okay, I know it looks like a 0 also, because you can see a kind of like an outline of a 0 over here. You can kind of see that, but if you kind of see, it is saying that it is a 5. Like you can see that there's this little thing. Yeah, sure, it kind of looks more like an S than a 5, but I mean it's there. It's there. So let's run it on image 1 for now. Image 1. So if we run it on image 1, what do we get? Alright, so image 1 is a lot more clear. It is a very clear image. It is a 0. Okay, let's look at what image 1 really is, because that's kind of more important. Damn, it is a 0. Alright, so what we're gonna do now is we're also gonna just say we're gonna do a plt dot show, and we're gonna do one little thing. We're just gonna say oops. Alright, I'm gonna do one little thing, just do 0, so it gets rid of that bracket. Alright, now let's try. Okay, now let's do it on 10 images. So let's do a for I in range 10. Let's do it on 10 random images. So random number is, you're gonna need random for it. Import random. Instead of random num, let's call it random index. Random dot randint. We're gonna do 0 to len of df. Alright, and then we just want to do this, and we're gonna do this. That's pretty much it. Yeah, let's run that now. Alright, there we go, it's actually working. Alright, so now we can see, we say action number 0, it is a 0. Action number 2, we can see a 2. I mean, 2 is the most distinct over here. 9 is 9, 7 is 7, 0 is 0, 2 is... It's a bit of an 8 more than a 2, but I can see a 2. But I mean, I get it, because an 8 and a 2 are very similar. I know you're probably thinking that I'm stupid right now, but think of it. An 8 is really just a 2 with those two things connected. So yeah. 1 and it gets a 1, 1 and it gets a 1, 4 and it gets a 4, 5, and it almost gets a 5. So yeah. Alright, so wow, this is actually a pretty, it is a decent autoencoder that we have over here. It is a pretty decent autoencoder. I mean, one thing that I can kind of just do, one little improvement. This was bugging me for some time. Yeah, I just want to segregate it a bit more, like just call it encoder block. We're just cleaning stuff up now. We're not actually writing any code. I want to type this. Alright, there we go. Alright, so this is the code for an autoencoder in pytorch. You could see we did this stuff without help. Like, when I say without help, I mean we didn't actually see any pre-made pytorch autoencoders. We used help from a classifier. I mean, it is very similar to an autoencoder technically speaking, but I mean, still, obviously we would have needed some help. But yeah, so we did this purely by just looking at documentation, understanding how stuff works, and we actually got a project in place. And it looks pretty good actually. I really like it. So I hope you enjoyed this video, and I hope you understood a lot from it. There's definitely a lot more to PyTorch than just a simple fully connected autoencoder. There is a lot. This isn't even the tip of the iceberg. But you know, you got to start somewhere, and this is where I am starting. So I hope you enjoyed this video, and if you did, like and subscribe to the channel, and you know, let me know what else it is that you want to see. I mean, I've been a lot more active on YouTube recently. If I upload this video like today or tomorrow, then yeah, you'll see that. I mean, I had like 2 streams and a video very like close to each other, and I did say I do have a lot more free time now, at least I hope and I guess. But yeah, alright, so that's it for this video. I hope you enjoyed it. If you did,